Good afternoon, everyone. Welcome. I'm David Hahn. I'm the Craig and Berge Dean of the College of Engineering, and I'd like to welcome everyone to our second webinar of the Spring 2023 Alumni Faculty Lecture Series. Our goal remains the same, and that is to share discussions on important topics and have a conversation with our alumni and friends, including many who generously support the college and have truly helped to make this happen. Today is International Women's Day, so I'd like to give a special welcome to our female alumni and supporters joining us today. It's great to be here and continue our discussions around issues of national and global significance. Last month, we talked about semiconductor manufacturing in the context of local and global implications. Today, we continue this theme with a topic that is a key aspect of the Arizona economy, noting that we produce about 75% of the nation's copper and is of national and global importance. And that is the topic of mining and critical minerals. In nearly every aspect of technology, from vehicle electrification to consumer electronics, to renewable energy generation and storage, and other decarbonization technologies, we are relying on critical minerals. These can range from copper to lithium to zinc to titanium. And it's a very exciting time for us. We've just brought the new School of Mining and Mineral Resources online, and we've attracted more than $15 million in state, corporate, and philanthropic investment in just the last 2 years, as we position the University of Arizona to be the world's leader in mining engineering and mineral resources. So it's exciting to have this conversation today. And I'm delighted to be joined by our faculty member, Kray LUXBACHER, and our alumnus, Greg Boyce, who I'd like to now introduce. Greg, welcome. Greg has a long career of leadership in the mining and energy sectors. He served as the president of Kennecott Minerals from 1993 to 1994, as the chief executive officer and president of the energy division for the United States of Rio Tinto from 1994 to 1999, and then as chief executive of the energy division of Rio Tinto globally from 2000 to 2003. Greg then served as the chief operating officer of Peabody Energy from 2003 to 2005, president from 2003 to 2007, and as chief executive officer in 2006 and executive chairman in 2007. He retired as CEO and chairman at the end of 2015. Greg is a former chairman of the National Mining Association, and is a member of the Business Roundtable and the Business Council. Greg received his Bachelor of Science degree in mining engineering from the University of Arizona and is a proud Wildcat. He currently serves on our executive advisory board for the School of Mining and Mineral Resources, and has been an excellent advisor to me personally as we've put forth this bold vision of growing this college and all things mining and mineral resources. Greg, welcome. I'd also like to introduce our second panelist and guest, Dr. Kray LUXBACHER. Kray is an expert in atmospheric monitoring, ventilation system characterization, mine fire simulation and prevention, and mine risk analysis. Kray received her BS, MS, and PhD degrees from Virginia Tech, all in mining engineering. After some time in industry, she was the first female tenure-track professor hired in her home department at Virginia Tech, and ultimately became the department head of the mining engineering department. We successfully recruited Kray to the University of Arizona last year, where she holds the newly established, in a great coincidence for today, the Gregory H and Lisa S. Boyce Endowed Department Leadership Chair in Mining and Geological Engineering as professor and department head. Welcome, Kray, and welcome, Greg. So we'd like to get started with a small slideshow to kind of frame this narrative in our chat today. So Kray, I'm going to turn this over to you. I see you're ready to go to kind of frame what mining workforce looks like, and then we'll move into our chat. Kray, it's all yours.
Thanks, David and Greg. I hope you feel free to jump in at any point. But make no mistake, mining workforce is really a very challenging problem right now. And I think there are lots of opportunities, and the University of Arizona is really leading the way. So those are the things I'm going to discuss. First, I'd like to start with our land grant acknowledgement. This is important to the University of Arizona, but as a mining engineer, it's especially important to acknowledge how we inhabit land and how we manage the communities that we work with. We respectfully acknowledge the University of Arizona is on the land and territories of Indigenous peoples. Today, Arizona is home to 22 federally recognized tribes, with Tucson being home to the Odom and the Yaqui. Committed to diversity and inclusion, the university strives to build sustainable relationships with sovereign native nations and indigenous communities through education offerings, partnerships, and community service.
Thank you.
So in talking about mining workforce, I want to give you a little bit of historical context, some trends in mining that are really affecting our workforce now and the needs that we have going forward, some data on workforce, and then where do we go from here and how is the University of Arizona positioned to lead? So I'll kick off with a quote from McKinsey that was just published 3 weeks ago, and it really sets the stage. McKinsey and Company said mining companies are experiencing a talent squeeze. 71% of mining leaders are finding the talent shortage is holding them back from delivering on production targets and strategic objectives. And 86% of mining executives tell us it's harder to recruit and retain the talent they need versus 2 years ago, especially in mine planning, process engineering, and digital, things like data science and automation. So to talk a little bit about workforce and safety, and maybe some of the things that people hear about mining and think, oh, it's dirty, it's a dirty industry, it's an unsafe industry. These are some data on injury and fatalities in mining. And they started in 1983, and you can see our workforce on an FTE basis, which shows just around 250,000 workers, which is low. There are actually more workers than that, but this is based on the FTE basis. That's the blue line. So we've seen a reduction in workforce across the country and a big reduction in the past century. In 1923, there were 862,000 coal miners alone in the United States. That doesn't count metal miners. If we look at the fatality rates, they have gone steadily down across the industry with some unfortunate spikes where we've had some catastrophic incidents. And then if we look at the injury rate, which is the red line, we see that steadily going down and really kind of leveling out. And I'm going to talk more about that in a minute. But the important thing to note is that if you look at the injury rate in mining, it is actually less than the injury rate in retail. So this is not the industry that many people imagine it to be. So some of the trends we're seeing right now, and I've been in the industry for about 20 years, and this is kind of the most exciting time I've ever seen. And this is driving changes in workforce. We're seeing a lot of automation, obviously. This is driven by, in part, lack of workers, but also driven by decarbonization efforts, safety and health benefits, and increasingly challenging deposits. We're going to have to mine stuff that's deeper, that's more geologically challenging, and that has less ore grade going forward. And then we look at environment, social, and governance. We need more diversity, equity, and inclusion in the workforce, and all the major mining companies are looking really closely at this. We're upskilling workers in the countries and regions where we operate. The expat model no longer works for mining. We're not going to take a bunch of Americans to a country and have them operate the mine there. We really need to upskill people in that country. We're looking for improved environmental outcomes. And social license is now a requirement. It's not an option. If you don't have social license from a community, you simply can't operate anymore. And refining and processing is a big issue right now. Skill and capacity and mineral beneficiation, all the things we do to make minerals valuable from the ore we mine, has to return to the United States. We have little capacity in the US right now. And one more quote for you that sort of sets the stage for maybe how the public is looking at mining, how investors are looking at mining, and how companies are looking at themselves. The same awareness and concern for environmental and social issues from societies that have led us to climate action is also a key barrier to the expansion of clean technologies. This is because the minerals and metals that are core inputs to these technologies involve extraction and production processes that are carbon intensive and can be highly disruptive to the environment and the communities where mines are located. So we're starting to see that people understand why we need critical minerals. They're key to all the decarbonization technologies that we want to see benefit society. But we still haven't gotten to the point where people say, okay, we do need mining, and actually we probably need it in our backyard. And to point that out a little bit, especially in our backyard here in Arizona, these are some of the clean energy technologies that we're really looking closely at in the next couple of decades. And you can see anything in red or yellow, there's a very high need for that mineral. Blue is a little bit lower. And there's copper sitting to the far left, and it's needed badly in almost every single one of these technologies, with the exception of geothermal and hydrogen. So in Arizona, this is especially critical right now. The other thing that not everyone understands is that really we can't just recycle what we already have. We simply don't have enough minerals to create these technologies right now. We don't have enough out of the ground. We don't have enough based on the production that's expected in the next 10 years. And you can see some of the really critical supply shortages that are expected over the next few years, with copper sitting sort of on the right-hand side, a pretty serious shortage there. So that's the supply to demand ratio that you see on the left. And for copper, that's almost at 0.6. The other issue I just talked about a moment ago is US refining capacity is quite low. We are mining a lot of copper in the United States, and we're refining some of it here, but much of it is shipped overseas for refining. If we look at rare earths, the situation is even more dire. We produced about 13% of global rare earths from the United States, but we refine virtually none of them. And one of the companies operated by a University of Arizona alum, I'm happy to say, is bringing refining of rare earths back to the United States, but it's not quite online yet. So, and where do you think all of these things are refined? Of course, they're refined in China, and they're refined in countries that don't have the environmental regulations that we have here. What's interesting to note too is if you look at what we are refining in the United States, it tends to be oil and natural gas. And that's a legacy of the oil issues that we had nearly 50 years ago, right? Where we really were a country in crisis. And we need to look at minerals the same way that we have to geopolitically have the capacity to refine our minerals. And back to automation, a quick example for you of what's happening in mining around automation. You often hear people say, well, we automate everything, we won't need this workforce anymore, but that is not true. We just need a different kind of workforce. So I got this example from a workshop I held last week around automation in mining. And we were talking about a remote mine in North America that operates very large haul trucks, 400-ton trucks. They pay over $100,000 a year in salary to their haul truck drivers. And they have 4 drivers per truck, 3 shifts plus somebody's off every time. So if they look at automation, they look at automating this fleet, they're still going to require about 3.5 skilled people for trucks. And that's going to be people performing preventative maintenance, people monitoring the data coming in from the trucks, and people remotely operating the fleet, making sure there's no problem with the fleet operations. So it really doesn't change the workforce substantially, but they definitely need a different set of skills. And we might be able to put them in different places. Rather than that remote location, we may be able to put them in an urban center where they're monitoring things remotely. And we could also potentially completely change fleet requirements. These very big trucks, one reason they're very big is so that we can just put one operator on that 400-ton load. But now we might be able to look at a totally different kind of fleet. And so as we look at new mines, we know they're going to be deeper, they're going to be hotter, they're going to have lower concentrations of the mineral that we're looking for, and we're going to need new methods for waste management as well. And a little bit on DEI. Mining's really a progressive industry. People are sometimes surprised to hear, and the major players take their workers and their workforce seriously. So if I look at examples from 3 of the major players right now, BHP wants to achieve gender balance by 2025 across their company. That is a very ambitious goal for a mining company, since nearly all of them are very much male dominated. Freeport-McMoRan is committed to fostering an inclusive culture. 99% of their employees must be from the countries in which they are operating. Rio Tinto has commissioned a workplace culture survey that I've read, and it was not entirely flattering. What they did was they released it publicly, which is pretty unusual, and they immediately started taking action on it. The other thing they did was they created a program for Indigenous leaders in their company in the countries that they operate in. And the picture below is the first all-female collegiate mine rescue team, which came out of the University of Arizona. So the new mining workforce doesn't just look different. They're going to do substantially different things than they're doing right now. And it's really kind of awe-inspiring when I think about the things the students we're educating right now are going to be doing in 20 years. They're going to design and maintain complex automation systems. The mine design and operations likely going to see a step change with human operators removed, different scales, and potentially new mining methods. And if you know anything about new mining methods, Hecla introduced a new mining method this year. But really, there haven't been any substantially new mining methods introduced since probably the middle of the last century. Increasingly harsh environments that are monitored almost exclusively by remote, movement of more ore for less product, And if we look at the tailings facilities we have now in Arizona, that means we're going to have even more waste that we have to manage. And we have to manage it differently than we're managing it now. Design of zero carbon systems for an industry that requires a lot of energy. So we're looking at electrification or battery power for almost nearly everything, possibly some hydrogen power as well. But of course, breaking and moving Earth is very energy intensive. Community relations and social license will be a core component, not just of the company, but of engineering. Every decision an engineer makes will come back to, do we have social license to do that? Improved environmental outcomes and environmentally benign approaches are going to be required. Circular economy and total mine life design is necessary. And of course, everybody's talking about off-earth mining. So when I look at trends in terms of education, our workforce challenges are around our hourly workforce, but also around our technical workforce, our college graduates. And if I look at the BS in mining engineering, first I have a gaping hole in the national data. I apologize for that. But the peak happened in 2015. And what you can see is that if you look at capital expenditures in mining, this is for the United States, but it generally applies in Canada and Australia as well. We lag capital expenditures by about 3 or 4 years, which is how long it takes to get a degree. And so you can see capital expenditures in gray peaked there in 2012, and then nationally, mining BS degrees peaked in 2015, and at Arizona, they peaked recently in 2016. And you can see they look relatively low in 2021, but what you can't get from this is that our enrollment is up moderately. So we will see degrees coming up after that. And the other thing that you'll notice is that capital expenditures are moving along. They're moving up, although a drop is expected. So that does help with our student enrollment. And I think that's really because students are looking at what's happening in industries, whether we know it or not. They're gleaning things from the news. They're gleaning things they see online, and they're making decisions, maybe not consciously, about what they're going to do. And so you can see the 3 peaks there. In a global context, we've seen the same trend in the United States, Canada, European Union, and Australia in all the major mining schools. But in China, we don't necessarily see that trend. It's very difficult to get data on Chinese enrollment in mining engineering, but there are 19 Chinese accredited programs with a total of 44. 3 of these report to the Society of Mining Professors, which is a global organization, and they reported 204 BS degrees in 2020. We could extrapolate that there are about 3,000 BS degrees in China being produced every year in mining engineering. And that doesn't include the other specialized areas that feed their mining industry. We don't necessarily have these specialized areas in the United States. We do have metallurgical, but it's an even a smaller group of people than we have in mining. And so in 2020, remember, we reported 182 BS mining engineers in the US. At its height in around 1980, the US was producing about 800 mining engineers with a BS. I'm not looking at graduate degrees. So what are we doing about it? That's the news, and those are the challenges. And I think that what we're doing about it is standing up the School of Mining and Mineral Resources with Greg's help. And this is a new transdisciplinary, future-focused mineral resources school designed for impact. And if you saw the trends in the industry, we definitely need mining engineers. You won't hear anyone advocate more for mining engineering than me. I think that society badly needs mining engineers, and it's the role of a land grant institution to produce them. But we also need a lot of other people. We need environmental scientists. We need civil engineers working in mining. We need mechanical engineers working in mining. We need data scientists. We need the whole suite of disciplines. And so the goal of the school is to really break down silos between both the disciplines here at the University of Arizona and all the stakeholders, professors, students, industry, government, and really be a transdisciplinary kind of school and something unique in the United States. I'm not aware of anything else like this in the United States. So it's not just about producing mining and chemical engineers. It's about producing lawyers that understand mineral law. It's about producing human resources professionals that want to work in mining. So if you look at what the school aims to do, there's a lot of interdisciplinary learning that's being stood up here at the University of Arizona, both at the graduate and the undergraduate levels, including a new minor in mineral resources that any student in the university can take. So for instance, any engineer can minor in mining engineering, but it would be hard for someone in the humanities to minor in mining engineering. They can minor in this new mineral resources program. We're really creating a global network of experts, and I do think this does have global impact, not just national impact. We're bringing together people in government, people in industry. And if you look at Arizona operations, we've got a lot of multinational companies that are operating here. We're trying to fill the pipeline, and that's really critical if you consider the data I just presented. The pipeline is not full right now, and there's far more demand than there is supply of people going into mining. And we're trying to make sure that people understand mining. Even if they remain opposed to it, at least they're well educated about why we need mining and what mining does, what mining companies do. So some of the things that we're doing right now, we have multiple degree options in environmental sciences, geosciences, global mining law, and of course in mining and geological engineering. So the school is co-administered by the College of Engineering and the College of Science. And so that's where we've really started to focus our efforts, but we'll be moving out to other colleges as well. And we have multiple centers that are helping us achieve both the degrees, but also some really impactful research for the industry. And I would point to the Center for Environmentally Sustainable Mining in the College of Science. They've been doing really good work on mine waste for many, many years and are well respected. So that's a real strength for the school, as is the Geotechnical Center for Excellence, the Mining Safety Center, the Tailings Center, which we have with Colorado School of Mines and Colorado State University, and the new Mine Hyperspectral Research Consortium. Oops. And so to give you a sense by the numbers of what we're doing, these are all programs that we want to grow and that we have capacity to grow. Like we could easily scale them. We've got lots of degrees enrolled in graduate and undergraduate research in geosciences and in mining. And hope to grow both of those. University of Arizona is a leader in providing graduate professional degrees in mining with over 50 students enrolled. And so what that means is I can take someone who has a background in business, someone who has a background in some other just engineering discipline, and they can get a Master of Engineering in mining engineering and very easily move into the industry. In terms of professional development, we've got lots of activity there. Professionally developing people in the industry, but also safety and technical rescue at some of our sites. And K through 12, I think, is one of the things we have to be most proud of. We have 2 full-time outreach professionals out of the school, and they contact over 1,000 K through 12 students annually. And they do this with really exciting hands-on projects. It's not just a presentation about mining. And then the other thing we have, which really attracted me to the University of Arizona, is the San Javier mine, the mining laboratory. And I think it is the best experiential learning and applied research venue in mining. And what I really envision as we stand up the school and as we involve industry is that this will be a technology hub, a place where we take students, we take people in industry to train them, and we're doing really cutting edge, innovative research in mining. And it's not just mining engineers working there, it's people from across the university. This mine is a multi-level mine with historic workings, but it also has a new modern 15 by 15 foot decline. No other experimental mine run by a university in the country has anything like it. So we can really test modern equipment. That is my pretty brief overview because I wanted to leave plenty of time for discussion. And this is one of our wonderful PhD candidates here in mining engineering.
Excellent. Thank you, Kray. If you want to unshare, we can get to the discussion. Thank you. Really set the stage nicely. Some of you have submitted questions, which I've pulled in advance, and I'll try to monitor in real time. But you've submitted some fantastic questions around workforce, mining, research, and all the related things that we do as a university. I'm going to start with you, Kray. You ended your presentation talking about the School of Mining and Mineral Resources. Let's just touch on that a little bit more from your perspective about, I'll focus on the word opportunities, like where can this take us in education and research?
So I mentioned, that we have a strong tradition of mining research across the university, but we've probably, like many large organizations, been sort of siloed in the way that we've done that. And I think the school will be really good at helping us to break down those silos. The other place that I see the school being really valuable is in the way that we work with industry and the way we communicate with industry. It's sort of a one-stop shop to get feedback, to iterate. And I think it'll make us much more innovative and much more nimble in our responses to the challenges that industry faces, and communities as well, not just industry.
Excellent. And Greg, you are a member of our executive advisory board for the new school. You've been with us from ground zero. What are your perspectives on the importance of the school and what it will do for workforce development? And we could even throw research into that.
Sure. Thanks, David. And first of all, Kray did a fabulous job with her presentation and putting the school into context. And I think everybody can see why we're so excited that she's now part of the University of Arizona family. So, yeah, the vision for the school was to really meet the needs of the new generation of, if you will, mining employee family. And that was across an entire spectrum of disciplines. Mining today, I mean, it always has been, but more so today, it is multidisciplinary and it needs to be integrated from exploration all the way through to reclamation, the whole life cycle of a mining operation. Integrated not only within the technologies used within mining and all those aspects, but also then integrated into the communities that it's located in its social license. So the whole concept of how we develop this workforce of the future, we focus on mining graduates, but another part of the university and one of the ways that of the school and one of the reasons we got funding from the state was upskilling and retraining existing workforces in mining today. So the kind of seminars and workshops that we'll be producing over time to be able to bring the current workforce up through and upskill the current workforce to meet future demand as well.
Excellent. Thank you. Kray, you talked about the environmental impact of mining. You talked about ore bodies are often deeper. They're sometimes less grade than we've seen in historically, and oftentimes they're closer to population centers, right? And so, what can we do to ensure that mining is done with minimal environmental impact? Today's mine isn't yesterday's mine, and you talked about that. How can we minimize that impact? How can we extend to restoration as part of the end of life cycle? And what are things we might be doing here on that front?
One thing that most companies see they need to do more of that they haven't done in the past is take a more holistic approach to mine design, so that it's not just what are we going to do? We're going to put this back when we're done. But from the day you start designing a mine, you really look at the environmental impacts and how you plan to reclaim that mine, and you do it as you go. It's not an afterthought. And when I look at environmental impacts in the United States, we are still having environmental impact, and in some cases negative ones. But if I speak to someone who's strongly against mining for environmental reasons, I would say, well, you should really want mining in the United States. We have the strictest environmental regulations in the world. And further to that, we need to really incentivize companies in our regulation to go beyond compliance, to work with communities to benefit them in some added way, whether it's, we're providing water to farmers because we've had to pump this water up, we're providing water to communities. We're creating something that the community wanted, whether it's a recreation area or something like that. But I really think we need to also incentivize companies to work more with communities in our regulation.
Mm-hmm. Excellent. Thank you. Greg, you spent your career in both energy and mining sectors, which are almost always global in scope. Can you comment on this current movement in the United States to ensure domestic sources of critical minerals, and what does that mean in the United States, and what does that mean to the global mining sectors?
Sure. Yeah, no, you're absolutely right. Both of these industries are global in nature. As when you look at almost all industries, we had gone through a 50-year period of time where open borders and sourcing from throughout the globe was the plan. Post-COVID, I think people have really looked at that and looking at supply chain factors and looking at where critical components, critical minerals should be coming from. Then you couple with that the clean energy or the clean technology economy that we're entering in terms of decarbonization goals. Kray showed the slide with all the new critical minerals. And so the U.S. found itself and a lot of other countries really behind the eight ball. China had the dominant position in production and refining. So now the question is, how do we bring some balance back? Well, that's going to be a difficult task. It's not that we don't have the resources here to develop, but we have to go back and work collaboratively with both federal and state governments to say, how can we access these minerals, develop them in an environmentally, socially responsible way that meets the needs of our critical economies, but allows us to have access. I mean, it's not enough for us to just say to Australia, well, if you incentivize your critical minerals, we'll buy them from you. We have to be able to develop our own. And that's going to take a new paradigm in terms of relationships between the regulators and even environmental groups to allow that to happen. It's not that we don't have the capability and the resources, but we have to change our permitting timeframes and our full view around whether mining is acceptable.
Absolutely. I agree with that. Kray, a lot of your technical experience is around mine safety. Do you want to comment on training protocols for mine workers? How have those evolved over time? You showed some mine safety data, but you want to, dig down a little deeper on that for those people that are sitting out there thinking about a career in mining and might be concerned that it's not safe. You mentioned just from an injury perspective, it's no different than much of the industry out there. You want to comment a little more deeper on mine safety and the evolution of mine safety?
Sure. I think one of the most interesting things in training that we're doing here at the University of Arizona is really the use of virtual reality for training. And so, we used to take a new miner who really had hardly been in a mine, whether it's a pit or underground at all, and put them on a piece of equipment with somebody experienced and say, okay, try it. But now we have virtual reality where we can really let them learn to run equipment in a safe and benign atmosphere. And that's one of the more exciting things. And the other thing we can do with those atmospheres is practice emergency drills. We can have them identify hazards and say, what would you do about that hazard? So I think that's one of the most exciting developments in training that we're seeing and something that we're involved in here. The other thing I'd say about injuries and fatalities in mining is we've seen, particularly around injuries, a change in the type of injury over the year. So it used to be that you might see catastrophic injury, something like a loss of an arm. But now what we see is musculoskeletal injury. And so these are injuries that come with age and repetitive motion. And they're difficult to prevent if you have a worker doing that thing. But with automation, I think we're about to see a real step change in those kinds of injuries because we're going to remove the worker from the repetitive task. So I do think you sort of saw that flat line, which frustrates the industry. They want to continue the decline. And I think we're about to see a step change there in safety.
Good. I'm going to pull a question that just came in from the audience. Stay technical for just a second, because I know you're literally working on funding around this area now in real time. So the idea of copper beneficiation enrichment, right? Is smelting still the important process, and how does that compare to solvent extractions? And you can tease out a little bit our plans for pilot scale facility where we can test new processes. What do you want to speak a little bit to state and maybe where things could go?
Smelting is still critically important to refining copper. There are only 2 copper smelters in the United States at this point. And we really do need to bring that back to the United States. It is a process that is not environmentally benign. And so it's one where we need lots of engineers looking at new ways to do it, whether it's solvent extraction or different kinds of smelting. Right now, it would be difficult for any US mining company that's either operating smelters to actually reduce their emissions any further. It would take $1 billion investment likely to do that. And so we're really looking at a step change there in terms of engineering and process. And it is critically important because climate change is a global problem. And I'm sometimes frustrated with the idea that we can simply ship our ore to China to be refined, where their emissions are going to be much higher than our emissions are here in the United States. So we're looking at the U of A at building a pilot refinery, smelter, mineral processing, where you could do practically any type of mineral processing you want to, a modular type facility at the pilot scale, not the lab scale. and really examine these processes and understand how we might create better processes in an interdisciplinary way, because we need chemical engineers working on this, we need material scientists working on this, we need environmental scientists working on this as well.
Excellent. Thank you. Thank you for that. Greg, as Kray noted in her introductory remarks and slides, we hear a lot of talk in the corporate world about ESG, environmental, social, and governance. You've really sat at the high levels of mining and energy for a while now. How has this evolved with time? And how does ESG affect corporate discussions in the mining sector? And where do you see this trend going and continuing?
Sure. Well, I think first and foremost, what you see right now is ESG conversations are taking place throughout an organization, whether it's at a mine site level, all the way up through the C-suite and board of directors. And it's happening all across not only the mining industry, but really all industries, and appropriately so. We're finally getting the focus to make what I would say is really good step change. Things like the BHP commitment, or as you know, I'm familiar with the Newmont organization, and they've been the Dow Jones #1 in their sustainability index for the mining and energy sector for a number of years. And so it starts with what you do around your environmental performance, obviously decarbonization and decarbonization targets. And reporting is a big component of that right now, but so is, I would say, water and the use of water, particularly in the mining industry. Then you've got all the areas around the social interactions, not only culturally with your workforce, but also with the communities that you're involved with. And then the governance aspects, and then of course, DEI, the diversity, the equity, and the inclusion. So I guess I would say, and certainly in my career, you went, 40 years ago, you talked about, we were doing the environmental permitting, and that was kind of our discussion. To now it's the full scope of all of those issues, and it's at the full levels and layers of the organizations.
Great. That's quite a change, right, that we've seen over the decades. Kray, we'll kind of stay with this topic a minute. You talked again in your slide, you gave some concrete examples of what companies are doing around DEI and social responsibility. You want to just elaborate a little more and then talk about how ESG and these efforts are in part of the school and part of Mining and Geological Engineering department?
Sure. I mean, DEI is a core component of ESG, among many other things. But one of the things the industry does, which I think has positioned it very well to look at DEI issues, is we've had this strong safety culture that's developed over probably 5 decades. And in a strong safety culture, a person like Greg Boyce, who as a CEO could go into a mine, and if a brand new worker, least seniority, saw him do something unsafe, they would feel empowered to say, Greg, I don't like what you're doing, stop doing it. And they would be thanked by him. So that creates a really inclusive atmosphere. It creates an atmosphere where people are willing to speak up when they see something wrong. And my point is, when you look at DEI and really creating organizations that have a good DEI culture, you have to have that kind of atmosphere to start with. And I'm certainly one data point. I can only speak for myself, but in my experience, the industry has that atmosphere already. So it's one step ahead. And then when we look at some of the things I mentioned other companies are doing, making sure that Indigenous people have opportunities for leadership, that people in country have opportunity for leadership. We're not just sending Americans out to run these massive mines. This is a really important component of DEI. And when I look at the school and mining engineering, we're working hard to make sure that women and underrepresented minorities can see themselves in these jobs, can look at them and say, wow, that sounds like a really fun career. That's something I want to do, and that we're supporting them. And we're doing things like we have a new Women in Mining chapter here at the University of Arizona. I would add the state of Arizona has the biggest Women in Mining chapter in the country. And those people are working really hard, men and women, to make sure that there are opportunities for underrepresented minorities. And finally, in the school and in the way that we teach, when I think about ESG, I think about DEI. 20 years ago, we started probably teaching classes in our mining curriculum about environment. And then we realized, oh, this should be in every single one of our classes. And so that's where we're headed with ESG, really, is integrating it into all the decisions that a mining engineer makes.
Fantastic. Good. Greg, you've led large interdisciplinary teams. Yes, you do have a degree in mining engineering as well as some business training, but what other technical disciplines are involved in mining today within the engineering and even from outside of engineering that you see as important?
Well, David, you look at all major mining companies today, and they are actually hiring every discipline. Maybe not so much the optical sciences at this point, although if they're doing diamond sorting, they're looking for optical science specialists.
Absolutely.
Yeah, when you first, I would step back and say, when you look at the industry, the workforce and the talent that each company hires really is the defining factor around success, because we can all buy the same equipment, we all chase the same resources, we're all using very similar technology. So the only thing that really differentiates mining companies is the culture and the people that they have. And so when you look at why is talent so important, why is it so critical to the needs, that really gives you your answer. It's key to the success. Mining engineering is a critical core competency, but you need, and Kray pointed it out earlier, we need legal professionals, we need automation and big data professionals. I mean, I hear more about cybersecurity and our networks, and particularly when you go into automated truck fleets, you can just imagine the amount of data and the technology that's involved with those types of things. Then you get into clean energy technologies and those types of things. So you need social scientists for your social engagements. You need the environmental scientists for your reclamation and for your ongoing operations. Civil engineers, mechanical. I mean, there really isn't a discipline, even anthropologists, there really isn't a discipline in the university. And I think I just described why we felt the School of Mineral Resources and that interdisciplinary approach was so critical to the future of education in Arizona.
That's great, Greg. Kray, I'll kind of stick with this theme. What are we, the University of Arizona, the School of Mining and Mineral Resources, the College of Engineering, and the Department of Mining and Geological Engineering? What are some things that we're doing to prepare students for this interdisciplinary and interconnected landscape?
I think one of the important things we're doing is putting students together before they graduate. We know that mining engineers are going to graduate and probably not work that much with other mining engineers. They'll work with environmental scientists. They'll work with lawyers on permitting. They'll work with chemical engineers and mechanical engineers. And so it's really important that we put our students together to solve problems and design things now. And one of the courses we're already doing that in, that's under the school and the department, is a sustainability course where we put students together from across the university and we give them sustainability design problems where perhaps an operation can't achieve social license, and say, how would you approach this community? That's one of the things that we're doing, is making sure those people are working together now, not just after they graduate.
Excellent. I'm going to kind of stay on this technology theme and again, pull a few questions from the audience. People have asked about, and I'll let you both kind of weigh in, roles of technologies. Greg, you kind of mentioned robotics, artificial intelligence, and water usage. What will we do to minimize dewatering programs? So I'll kind of throw out watering, robotics, AI, autonomy, and let both of you comment as you'd like on maybe trends or opportunities.
Go ahead, Greg. I've had my say on trends.
well, I think you've covered a number of them, David. I mean, it's hard to imagine any technology that isn't going to get involved in a mining discipline at some point in time. But if you just take water, for instance, water runs the gamut for how do you absolutely minimize freshwater usage in an operation? How do you maximize recycle of water that is used? And then in scarce areas of water availability, how do you develop new sources? And that may be desalination technology. So you've got water technologies, you've got pumping technologies, more energy efficient pumping. You've got water treatment technologies. You may have desalination technologies. You look at Chile right now, they're running desalination
plants and piping water up into the high deserts in order to run their mineral processing plants. We're talking about that here in Arizona because of the low level of water in the Colorado River, and maybe doing that from the Gulf of California. So that's just one area, water. Then you got air technologies, reclamation technologies, agricultural technologies. I can just go on and on. As you can see, there really isn't a limit to the types of fields and areas that are needed within the context of a mining enterprise.
Absolutely. Kray, do you want to talk a little bit about maybe just autonomy? I know we've hired Natalie Rousseau, who has a PhD in electrical engineering, working on autonomy. How do you see that? I think I would say that mining was one of the leaders in implementing autonomous driving, right? Before we ever heard of some of the autonomous cars, they've been running mine trucks remotely. They've been doing automated dispatch. I know Mark Baker did some of that early work. So what do you want to comment on that?
Yeah, absolutely. I mean, when we look at automation and the development of it, first of all, mining companies are the largest automation projects on the planet. If a student wants to do automation, I say, come to mining.
Yep.
But we were looking at things like proximity detection and automated vehicles back in the 90s, well before we saw the Teslas come along. And so we've really pioneered a lot of that technology and continue to. And as we look at automation, it's important that we have this interdisciplinary group of faculty like Natalie, who has an electrical engineering degree. As we automate equipment, mine plans are going to change entirely. Right now, a haul road is designed for two humans to pass each other in massive haul trucks. So there has to be some give there. They might not be perfectly aligned, but once we automate that, we're going to change the design of our mines. And so it's really an exciting time in automation and in data science. If you talk to companies, they will generally tell you we have so much data coming in, we don't really know what to do with it at this point. It's just more than can be managed. And really, it's a frontier for data science, I think.
I totally agree. I'll kind of toss up question to both of you. Kray, you kind of teased in your opening presentation, and I get this question a lot. What is happening with mining in space? And it's a common question. I'll let each of you have your take on that. Definitely presents some challenges. Not going to put a 400-ton haul truck on an asteroid, that's for sure. But what are the opportunities? Where is this going?
When I look at off-Earth mining, the first thing I'd say is we're doing it. Our students are on design teams that are competing at NASA in terms of in-situ resource extraction and robotics. We have faculty such as Momo Mayas who are funded by NASA to look at these things. So we're actively doing it. I don't try to sell the job too often to students because not that many mining engineers are currently being hired to do it, but they are being hired. I have a past student who is now a mining engineer for SpaceX. So it is something that companies are investing in, and they're hiring mining engineers. And when I look at what will need to be done to mine Mars, the moon, or asteroids, they're automated systems. They're probably at a different scale, but they're going to be doing the exact same things that we're doing on Earth. And we're going to be doing it remotely, just like we are on Earth. So I see, a great opportunity for mining engineers who want to get involved in space. And the other thing I would add, I gave a lecture to students about this, is I was looking at some of the things that space companies were saying about mining off Earth. And essentially, some of their CEOs were saying, look, we'll just go mine Mars so that we don't mess up Earth. And you would never hear a mining CEO say that. And that's not the approach we should take to off-Earth mining either. So I think our students who are so well-versed in ESG, they have a lot to offer that industry. If you go look at those companies, you won't find much on their websites about ESG.
Very interesting. And Greg, I'll have you put your CEO hat back on because you must get asked all the time, in your executive group, your business roundtables, tell us about space mining and the economics. And what do you hear? Well, how do you view this?
Well, it's an interesting concept, and it's one that I think is early days in terms of the look. I will tell you, back in the 80s, it was all about deep sea mining and ocean, mining of the nodules in the ocean, which I think maybe has a little more near-term opportunity than space mining. But if you have the Elon Musks of the world thinking that critical minerals are going to have to come from space, it might get accelerated in terms of its look. But I will say that it's my own view that the advancement in technologies to be able to mine what we know exists in the Earth's crust are going to allow us to continue to access and develop that over a fairly long period of time. And so I think the space mining is critical for developing things that may be used as, we go out farther in space, but it's going to be over a longer period of time.
That's great. Greg, I'm just going to stick with you for a moment. You've been a big help in establishing the school, but I'll ask, how do you see and what can the state of Arizona, state government do to sustain and build, the mining and critical mineral industry here?
Well, I think the school has been a great start because, as you know, David, we got great support from the state legislature for some of the initial funding and for developing some of the programs for training. And so there's clearly a recognition that the C in our 5 C's of copper for the state of Arizona is still a critical economic revenue generator, and the state is endowed with tremendous copper assets yet to be developed. I think the state could probably take a lead in working with the federal government and looking at the permitting and the regulatory regimes around how you develop new operations. Clearly, they have to be done environmentally sound, socially sound, with full involvement from the local communities and the impacted folks. But we need to get to when I graduated and my 40-year career, we started out with the rule of thumb was you could permit an operation in 5 to 7 years. Well, now it's 15 plus years if you're lucky. And if we're going to meet the demands of critical minerals, and if we're going to continue to develop within the state of Arizona our copper primacy, we're going to need to fundamentally rethink how all of that works. So I think the state is already starting with the workforce development. Obviously, we want them to really continually support the school. But I think we also have to look at how do we develop or enable continued development of mineral resources in the state of Arizona.
Absolutely. I was listening to talk last week, and what the person said is that from the mining industry perspective, certainty and sort of timeliness are critical to developing these big projects, right? If there's no certainty, if there's not a time horizon that is known, it becomes impossible to invest billions of dollars of capital. So good, that's excellent. Kray, to the vision for the new School of Mining and Mineral Resources, you kind of outlaid it. Talk a little bit of how that complements and then maybe differentiate Mining and Geological Engineering Department, which goes back to the 100 years in the origins of this university and this college.
So, by its very nature, mining engineering is highly interdisciplinary. We take lots of engineering disciplines and we kind of apply them all to mining, and we pull in specialists as we need to. But as I look at the school, they're really going to do that on a much broader scale. So, I'm not well versed in what a psychologist needs to know who's going to do behavioral safety at a mine. That's something the school can bring to bear. They can bring to bear law programs. They can bring to bear human resources programs for the heavy industries. And they can also serve as a conduit with industry and communities to say, this is what we need students to be learning across the university, not just in mining engineering. And that's really where I see a great strength for the school and a pathway for us in mining engineering to be more involved with all of those programs.
Excellent. I'm going to pull a question. I noted Mark Baker earlier on some of the early automation in mining. He asked about change management, what we can do to teach students that. I would say if there's probably one word that describes the mining industry right now, it's dynamic, right? We're changing global sourcing. It's the supply is projected, as you noted, Kray, to exceed demand. So change management is going to be a part of that industry. What are we doing things in our school, in your department, to kind of teach students about change management?
There are things we're doing and things I see that we need to do better. And even in the way that we give a student a design project. It used to be that we would say, here's your design project, take the semester, go after it, solve it, come up with a good solution. Now we tend to be far more iterative, and we tend to throw wrenches into the design project as they go. And in fact, there's a national competition our students participate in where they do a phase 1 design, and then they get to the competition, and then the judges say, okay, you've got to reduce your capital expenditures by 30%. What are you going to do now? So these are the kind of things we can throw into our technical assignments to change the way that our students work, and so that they can adapt to change. The other thing I see that we can do well is we used to teach students, okay, do a lab report, write a technical lab report, make sure that your manager can use that to make decisions. But now we need our students to be able to go out in a community and verbally discuss their mine plan in layman's terms, and make a community understand why it's good for them, and listen to what that community says, and come back and iterate, and maybe change their plans based on what the community values. And so that kind of management is tricky to teach engineers, and I think it's something that we're still learning and investigating how to do.
Excellent. So many.
David, one other thing I might add to that is engineers, this whole process of working through a really collaborative program is critical, because as engineers, we have a tendency to, we got our degree, we know all of the technical aspects of this job. So when we go out into the workforce, we don't necessarily listen as well as we should to the 20, 30, 40 years of experience of the people that are there at the operations. And I think that, as Kray talked about, listening is a critical skill. And I think the more collaboration that takes place across all of these disciplines, the more our engineers have to learn that listening skill, and then how to integrate those different views into their decision-making process.
Excellent. One person also asked online about the role of, I guess you could say, public relations and marketing, and I'll just answer that question. The school has engaged an external marketing consultant, a global company that has experience in this area, and we do plan to have a pretty formidable marketing public relations campaign around the school to not only put out the word that mining today is different from yesterday, to talk about the positives of sustainability and ESG, but also then to help recruit students into mining, which is where we started this conversation, supplying that critical workforce need. So we're excited about the campaign around the school to the world, to position ourselves as the world's leader. We're coming up on the top of the hour, so I'll give you each about a minute or so to pull out your crystal ball and say, what are some things you see possibly in the mining industry 20 years from now? I'll go to Greg and then Kray.
Well, I think we've touched a lot of those bases. I see 20 years from now, we're going to see a highly automated, artificial intelligence driven operation with less people in harm's way, if you will. Even though we've made great strides on safety, it does have geotechnical risk and other risks. And you're going to see operations that have less footprint, that externally their environmental impact is much less, and hopefully, in my view, the benefits to the local social fabric are going to be greater than they have been in the past.
Wonderful vision. Kray.
I agree on automation. It's all the industry's talking about right now is automation. And I think that's going to revolutionize the workforce as well. It's going to offer remote opportunities, different opportunities to different disciplines, and that's important. The other area I see changing a lot will be waste management and how we deal with mine waste. I could envision that we will mine underground a lot more than we currently do, so that we're not disturbing the surface as much, and perhaps managing our waste by backfill techniques where we put it back underground more than in tailing storage facilities like we do now.
Excellent. Good. Well, I think you both painted a great picture of what mining means in 2023 and where it's going, the importance of it to society, the opportunities. We're an education institution, the great opportunities for our students to really contribute to the betterment of the world through mining and critical minerals. So I think, I hope our audience enjoyed our discussions. We'll be back a month from now to talk about, with Dr. Kim Ogden from Chemical Engineering, to talk a little bit about some of the sustainability around water and plant-based systems So I'm excited about that. But today, Greg, I want to thank you as always for joining us and giving us your time. And Kray, thank you for painting a very positive picture of where we're going as a program. And we're glad that you're with us. Have a great day. Thanks.
Thank you all.
Thank you, David. Thanks, everyone.
Take care.